During. Ah, shoot. Darn, man.
Welcome back again to the class. Do you have any question on schedule or items? Please let me know. Jihu, can you close the audios which is generating noise? And we had a nice midterm exam last week, and this week we will cover finish up the ocean renewable energy part 2 by Johnson and myself and Sungwon. We lead the discussion session. And also on Thursday also I will be in the United States, so we will have another Zoom only meet classes about underwater acoustic. Right? No question here. Then I can move on to my part of TR for 3, ocean renewable energy, and mostly focusing on current and thermal energy. And Doyeon will cover solar and biomass. And here is a chart coming from different sources of power density, or another word is energy density. So for the renewable energy, solar, wind, and two are competing each other. We see that solar has more density. As you see in the below, there is also a list of solar and wind. And also you see that tidal stream and then solar power concentration. So there are different bases of energy density. So it is another view of size of equipment, and then solar is not good in terms of size. It should have a big area, and energy sources also in the bottom. There are table for, and the bottom there is hydro, wind, and solar thermal. There is a cost item, levelized cost. So cheaper is better, right? So hydro and wind onshore is cheaper, and so gas, CC is cheap. So they are competing each other for different sources. And current energy, there is a surface current and there is a deep ocean current. So usually we are talking about surface current with a Ekman spiral effect, and depth is about 100 meters up to, depending on the wave size, and also coastal currents I belong to. Deep ocean current is coming from density and temperature differences between deep water. But this is slow, but this is very large scale, slow and large scale, global conveyor belt, we call this. And then this is ocean conveyor belt. You see that the size of conveyor belt covering whole ocean of the globe, but it is very slow. So we see that there's a video how it's going with this ocean current.
Tourists. Tourists that turn into scientists. Tourists taking photos that are analyzed by AI. So researchers can help life underwater flourish.
In 1992, a cargo ship carrying bath toys got caught in a storm. Shipping containers washed overboard, and the waves swept 28,000 rubber ducks and other toys into the North Pacific. But they didn't stick together. Quite the opposite. The ducks have since washed up all over the world, and researchers have used their paths to chart a better understanding of ocean currents. Ocean currents are driven by a range of sources: the wind, tides, changes in water density, and the rotation of the Earth. The topography of the ocean floor and the shoreline modifies those motions, causing currents to speed up, slow down, or change direction. Ocean currents fall into two main categories: surface currents and deep ocean currents. Surface currents control the motion of the top 10% of the ocean's water, while deep ocean currents mobilize the other 90%. Though they have different causes, surface and deep ocean currents influence each other in an intricate dance that keeps the entire ocean moving. Near the shore, surface currents are driven by both the wind and tides, which draw water back and forth as the water level falls and rises. Meanwhile, in the open ocean, wind is the major force behind surface currents. As wind blows over the ocean, it drags the top layers of water along with it. That moving water pulls on the layers underneath, and those pull on the ones beneath them. In fact, water as deep as 400 meters is still affected by the wind at the ocean's surface. If you zoom out to look at the patterns of surface currents all over the Earth, you'll see that they form big loops called gyres, which travel clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. That's because of the way the Earth's rotation affects the wind patterns that give rise to these currents. If the Earth didn't rotate, air and water would simply move back and forth between low pressure at the equator and high pressure at the poles. But as the Earth spins, air moving from the equator to the North Pole is deflected eastward, and air moving back down is deflected westward. The mirror image happens in the southern hemisphere, so that the major streams of wind form loop-like patterns around the ocean basins. This is called the Coriolis effect. The winds push the ocean beneath them into the same rotating gyres, and because water holds onto heat more effectively than air, these currents help redistribute warmth around the globe. Unlike surface currents, deep ocean currents are driven primarily by changes in the density of seawater. As water moves towards the North Pole, it gets colder. It also has a higher concentration of salt, because the ice crystals that form trap water while leaving salt behind. This cold, salty water is more dense, so it sinks, and warmer surface water takes its place, setting up a vertical current called thermohaline circulation. Thermohaline circulation of deep water and wind-driven surface currents combine to form a winding loop called the global conveyor belt. As water moves from the depths of the ocean to the surface, it carries nutrients that nourish the microorganisms which form the base of many ocean food chains. The global conveyor belt is the longest current in the world, snaking all around the globe, but it only moves a few centimeters per second. It could take a drop of water 1,000 years to make the full trip. However, rising sea temperatures are causing the conveyor belt to seemingly slow down. Models show this causing havoc with weather systems on both sides of the Atlantic, and no one knows what would happen if it continues to slow or if it stopped altogether. The only way we'll be able to forecast correctly and prepare accordingly will be to continue to study currents and the powerful forces that shape them. What about
All right. Nice video there. And then the current energy, we are talking about renewable energy. So we can get some energy from current. Energy potential. The speed is slower than wind, but the water is 100 times dense than air. That's why we have a more potential than wind per say size. So 12 mile per hour ocean current would have energy output equal to 112 mile per hour wind. This is very typhoon-like wind. And Gulf Stream has a big energy, so if we catch thousands of them, that is why Florida energy needs. So it's a big potential there. And Kuroshio Current is nearby Korean Peninsula and Japan. And then there is a west side of North Pacific Ocean. Right? And we already saw this video at the beginning of our class. So I'll skip over there. This is coming from NASA. And then current energy underwater. So current energy, we may use a submerged water turbine. Looks similar to wind turbine, but different density of water. Similar to wind turbine, but since to the ocean floor, there are two types of horizontal and vertical, similar to again to the wind power. And then this is a sample case of Japan. Kyushu Island is right top. There is a red colored island. We call this Kyushu. And Nagasaki is a city of Kyushu. And at the bottom, there's a more detailed map of this one. And also it is output of 2 megawatts. And diameter is very small comparing to the wind turbine. And then current energy, 3 major currents in the United States: the Gulf Stream, Florida, and California, as we expect. And here is another video for ocean current. Let's see.
We hear about strange things from distant places being washed up on our shores all the time. But how do they get there? Ocean currents are the movements of surface water in the oceans. Their direction is influenced by many factors, including the rotation of the Earth, the size and shapes of the continents, the prevailing winds, and even water density. Ocean currents caused by prevailing winds are called drift currents. In the northern hemisphere, the circulation of the oceans is clockwise, and in the southern hemisphere, the currents are anti-clockwise. Currents originating from the polar regions carry cold water. There's the California current, the Peru or Humboldt current, the Labrador, Canaries, Benguela, the Antarctic circumpolar currents, and the Oyashio. Currents originating from the equatorial regions carry warm water. There's the Gulf Stream and North Atlantic Drift, the Brazil Current, the North and South Equatorial Currents, and the Kuroshio. So perhaps it's not so surprising that many of the items that are washed ashore originate from far-off places, thousands of miles away.
Okay, good one. Any questions? Continue on thermal energy. This is different type. Different thermal. Two types of thermal energy. One is the geothermal, that is a land-based one. Ocean thermal is called as a short name as OTEC. Oh, there is another video for this. See this. Watch the video.
Did you know that we can use the natural temperature differences in oceans to produce clean electricity, day and night, and all year round? This is called ocean thermal energy conversion, or OTEC. It works best in the tropical equatorial zone. Here, the ocean temperature difference is at least 20 degrees Celsius throughout the year. How does it work? The ocean's warm surface water vaporizes a working fluid with a low boiling point, ammonia for example. The vapor expands and spins a turbine that is coupled to a generator that produces electricity. The vapor is then cooled by cold, deep seawater. That way, the working fluid condenses back into a liquid and you can reuse it. This makes it a continuous electricity generating cycle. OTEC can become an important renewable energy source.
Right. Move on to next slide then. So how to use of geothermal energy? This is land-based one. Usually the source is very hot, more than 100 degrees Celsius. The hot dry rocks. And then they use injection of water, produce pressurized steam, and then we can use that steam for rotation of turbine. All right, that is all I prepared for today. Have any questions? No. Move, invite Do-hyun for this portion of lecture. Do-hyun, please.
Hello, everyone. I'm Do-hyun Kim. Can you see the slide?
Yes.
Yes.
In this class, we'll cover the topics of solar and biomass energy among ocean renewable energy sources. A total of 174 petawatts of incoming energy with 120 petawatts available per year. This corresponds to a value of 300 watts per square meter. 0.02% of available solar energy could replace all other energy resources. Energy radiated on the Earth in 1 hour is greater than all the energy the world uses in 1 year. We have a video about solar energy.
Sound is not coming. Did you check the option for audio? Otherwise, you need to unshare and share again and using the audio option. Unshare first. The screen. 화면 공유 중지. No, sound is not coming. You should unshare. 화면 공유를
그 화면 공유 해제하시고 다시 소리 공유 켜고 다시 공유를 해야 될 겁니다.
공유를 다시 하시면서 옵션 맨 밑에 왼쪽에
네.
옵션 박스.
Solar. Solar
들립니다.
energy, the most abundant renewable energy source in the world. Solar energy systems employ technologies that convert the sun's heat or light to another form of energy for use. There are two categories of technologies that harness solar energy: solar photovoltaics and solar thermal. Solar photovoltaic, or PV, is a technology that converts sunlight into direct current electricity by using semiconductors. In contrast, solar thermal is a technology that utilizes the heat energy from the sun for heating or electricity production. Solar is a renewable resource and does not emit any greenhouse gases. However, efficiency and intermittency are issues. Since sunlight is dependent on location, season, and time of day, harnessing the energy from the sun is a challenge. That's solar.
There are solar energy technologies. These include daylighting, passive solar heating, active solar heating, concentrating solar thermal, and photovoltaics. First, passive solar technologies convert sunlight into usable heat and cause air movement for ventilating to heat and cool living spaces without active mechanical or electrical devices. This is the principle for passive solar design: collector, absorber, thermal mass distribution, and control. Active solar heating systems have devices to convert the sun's energy into a more usable form, such as hot water or electricity. Photovoltaic system convert sunlight directly into electricity. We use this technology in calculators and wristwatches every day. Next, we have concentrating solar power technology. Mirrors concentrate sunlight onto a single point, where water is turned into steam and used to generate electricity through a turbine. This technology has the disadvantages of high cost. Aquatic biomass energy technologies involves utilizing water environments to reduce land utilization. Aquatic environments include natural or artificial basins, salty and fresh waters. Fisheries are interesting candidates, coupling water treatment and aquatic biomass growing. Let's watch a video about algae farm.
We all need fuel to get around, and as America takes steps to improve our energy security, homegrown fuel sources are more important than ever. The Energy Department is researching one of the fuel sources of the future found here in algae. Have a look at this algae farm. These large man-made ponds are called raceways, and they cultivate a new crop of algae every few weeks. You see, algae, or more correctly, microalgae, are very small aquatic organisms that convert sunlight into energy. Some of these algae store energy in the form of natural oils. Under the right conditions, algae can make a lot of oil that can be converted into biofuels. Algae could potentially produce up to 60 times more oil per acre than land-based plants. Extract that oil, and you have the raw materials to make fuel for cars, trucks, trains, and planes. In the future, anything that runs on gasoline and diesel could also use biofuel from algae. The oil is extracted by breaking down the cell structure of the algae. This can be done by using solvents or sound waves. After the oil is extracted, then it is further processed at an integrated biorefinery, or in the future, at a traditional oil refinery. Another great benefit of algae? Consider this. Like plants, algae needs carbon dioxide to grow, and that's good for the environment, since it takes CO2 out of the atmosphere, making it a nearly carbon-neutral fuel source. There may even be opportunities to build algae farms next to power plants that use fossil fuels, actually using CO2 exhaust to feed algae ponds. There are over 100,000 different strains of algae. Some grow better in different climates, or in freshwater, saltwater, or even wastewater. So, scientists are testing different algae under many different conditions to find the best strains and develop the most efficient farming practices. While commercial production is still a ways off, algae holds great promise to become a reliable homegrown fuel source to reduce our nation's reliance on foreign oil.
Algae fuel is an alternative to fossil fuel that uses algae as its source. This table shows comparison of some sources of biofuel. It can be seen that the diet of microalgae is much higher compared to other crops. These are pictures of an algae farm. Aquatic biomass energy is actively being developed in Korea as well. These pictures are examples of ocean biomass system in Korea. Thank you for listening.
All right. We are going next. Okay. And we may invite Sungwon Lee for the discussion session. Sungwon, are you ready for discussion? Good.
Can you see my PPT slide?
Yes.
Well, hearing.
Okay, so I will start today's discussion session. Today I will lead the discussion session about solar and bioenergy. So let's talk about the solar energy potential. So according to this picture, can you calculate how many percentage do we need from solar energy to meet global energy usage?
So it is around 0.01% of the solar energy.
Yes, you're right. So so if you see this picture, there is very big solar energy resources from the universe. So if we can use the core of the solar energy, we can easily meet the global energy usage. So if you see the picture in the right side, these materials coming from the International Energy Agency, which is about global electricity demand increases and renewable energy generation growth from 2019 to 2025. So there's, if you see this yellow part is about the photovoltaics. So it takes a big percentage of global electricity demand increase. So we can know that the developing solar energy is very important. So next, so I will talk about the solar energy technologies. So I will give the 4 types of solar energy technologies: passive solar heating, active solar heating, concentrating solar thermal, and photovoltaics. Can you connect the word and the number that is related correctly? No one else?
So it's 4, 3, 2, and 1.
So first one is 4.
Yep.
And 3.
4, 3, 2, 1.
Thank you for answering my questions. So it's correct. So this one, first one is a photovoltaics, which is called as PV cell, and second is about concentrating solar thermal. By using concentrating mirror to reflect the solar energy to and concentrate the solar energy into one point or line. So, and 3 is active solar heating, and 4 is about passive solar heating. So I will move to the passive solar heating. If you see the picture in the left side, there is 5 elements of passive solar heating. First one is the collector part, and second is the absorber part, and third one is thermal mass and distribution and control part. So is there any opinions that what condition of these 5 elements should have? For example, the collector has to shoot I must collect the sunlight from the sun. Yeah, kind of that. Is there any opinion? Uh, if if you don't have any opinion, so I will show my opinion. So for the collector parts, so windows, the sunlight can go through easily, not be reflected, because we use the solar energy from the sun. So the sunlight should go through the window easily. And in the absorber part, we have to use the dark surface that can easily absorb the light. For example, like black color. Black color can easily absorb the light. And third, thermal and mass is we have to use materials that can store the heat. Of course, we have to heat up the room of the house, so we have to store the heat in the thermal mass. And fourth, the heat distribution must be happened in the room. So we have to design the room that heat can be circulated easily. And in the control side, we have to choose the moderate length. So if you see the picture of left, when in the summer, the height of the sun is really high. So if the control size is too short, the light can come, most of the light can come through the window, so it will be heated very much. So in the summer, we have to control the length more, more longly, and in the winter we have to control this size short. So next one. So is there any opinion that pros and cons of passive solar heating? Anyone else?
Yes, one cons could be that you are not managing your amount of energy, so it will be difficult to be predictable.
Predictable.
So, yes, but for cons, it's unpredictable.
So you mean it's a
Excuse me.
cons of the passive?
Yeah.
So, okay. How about the pros? Is there any opinion for this one?
It's a renewable
Renewable.
energy.
Yes, it's a renewable. Is a carbon neutral methods, because we use the solar energy from the sun, so it is the renewable energy methods. So so this one is my opinion. So if you see the picture, we can use the passive solar heating by only designing the room of the house. So it is very simple to use solar passive heating system, because there is not much component to make this kind of systems. And also energy efficient, it's very energy efficiency, because we do not rely on external power source such as a pump or a heat exchanger. And also it is very lower initial cost, because there is not much component in this system, so the initial cost is very low. And lastly, the durability is very high compared to the active system, because there is fewer moving parts. So such as maybe the control part will be the moving part in this case. But there are cons too. So as you say, it can be very unpredictable, because we couldn't control the passive system by ourselves easily. So it could be the limited control. And also, like I said, is it very dependent on the design. So we have to design the room that is very good at circulating heat easily. Yeah, kind of that. So also it's a very high reliability to the sun energy. So it's highly dependent on the weather. So these are the cons of the passive solar heating, and these are the pros of the passive solar heating. So I will move to the active solar heating. So this picture is about the active solar heating. So you can see a lot of components here. Which component is needed for the active solar heating? There is an answer here, so you can find out the answer easily.
Yeah, so you need first a solar collector to collect the energy, and then you have to find a way to use and transport it into the house. So there in this drawing, it's like a pump with water distribution system.
Yeah, you're right. So this one is my opinion. So as it says, we need a solar collector from the outside because we have to collect the heat from the solar. So we should use the dark color plates that absorb heat in the solar collector. So, and also we have to use pump to circulate the fluid carrying the heat. So by circulating, while the fluid is circulating in the line, the water is heated in the solar collector. And then when it moves to the water tank, it emits the heat into the water. So it heated up the water in the water tank. And also we need the heat exchanger, exchange the heat to other fluid lines to heat up the house. So this line. So while the fluid in this line is heated up and circulated and goes through the radiator. So in the radiator, it emits the heat to warm up the house. So these four kind of component is needed for the active solar heating. So next one is pros and cons of active solar heating to compare to the passive solar heating. So are there any opinions for this one? So I will give you a hint. So there are a lot of components in this active solar heating. So how could be the pros and cons of this components thing?
One of the pros are that it is still a renewable energy, like passive heating, but you can control and manage your energy, so it's more predictable and more efficient.
Yeah, you're right. And how about the cons?
For cons, there are lots of components to be installed, so it is very complicated to make the active solar heating system.
Yeah, that's also right. Thank you for the answering. Are there any opinions? Okay, then I will move to my opinions. So, like you guys said, it is high efficiency, and also it has a greater control property because we use the pump, so we can control pump easily, and also we can store the heat very easily compared to the passive solar heating because we have a lot of components like pump and heat exchanger. So it has a less reliability to the weather condition compared to the passive solar heating. And also there are cons in here. So like you guys said, it has a high complexity compared to the passive heating because it requires pumps, controllers, and heat exchangers. So also it has a high cost, about because of these components, and and it has a high energy consumption compared to the passive solar heating because we have to use the pump and control. So we need the extra energy source. And lastly, there is a cost of maintenance for the components. So these are the cons and the pros of the solar heating. So I will move the concentrating solar power. So this picture is about the concentrating solar power. So in this system, tracking the sun is the important part in concentrating solar power. Can you guess why? Is there any opinion for this question?
It's because if you are tracking the sun, you can be able to find more energy. If you are not tracking it, you will lose energy and not be efficient during all the day.
Yes, you are right. So this is the answer. So when the sun is moved here to here, the angle of incident will be changed. So the reflected solar light cannot be concentrated in the solar receiver. So we have to change the angle of this mirror according to the sun moving. And also in this case, the same. So the reason is because of the sun's moving. And next one, I will talk about the photovoltaics. So what is the main different principle with other solar technology for generating power?
The main difference is that in photovoltaics, you are converting the energy of the sun in electricity and not in the other way.
Yes, you're right. So we can convert the solar light directly into the electricity. When we use the other technology, we have to use solar energy to heat up the fluids such as water. So after that, heat up the water to make the vapor, and by using the vapor, by using the vapor to rotate the turbine. And so there is a medium stage for that one, but in photovoltaics, we can directly use sunlight into the electricity. So next one is the solar energy in ocean. So let's see short videos of this.
Ocean Sun, a bold solution to our global energy needs. The world is in need of clean energy. In recent years, solar power has proven itself to be the most efficient source. Yet, in order to produce large amounts of energy, solar power plants require vast areas of land. Sufficient land areas cannot be found near the densely populated places where power is consumed, and agricultural and recreational spaces cannot be sacrificed. This results in substantial transmission costs from the power plant to the consumer. Around the globe, most people and most large cities are located in coastal areas with the open ocean right on their doorstep. Using Ocean Sun's solution, combined with large free areas of the sea, we can obtain clean and cost-effective renewable energy production close to populated areas. The power plants can be conveniently positioned out of sight and with transmission cables placed on the seabed. The direct cooling effect of the ocean greatly increases energy production, making ocean sun plants more cost-effective than land-based installations. They have also been designed to withstand harsh offshore weather conditions. Ocean Sun now successfully operates several prototypes on the west coast of Norway. This area offers a wide range of sea conditions ideal for further development. The hydroelastic membrane has a proven capacity to reduce wave impact and offers a protective environment for the solar modules. Ocean Sun's patented solution is based on marinized modules of commodity crystalline silicon solar cells. The modules rest on a thin membrane, offering low-cost deployment and easy access. The system is built with durable materials founded on world-class maritime and aluminium know-how. The next step will be city-scale installations. In the quest for widespread renewable energy, we dare to say that we have the solution.
So my next question is, what do we have to change when we want to use solar energy in the ocean? Anyone else? Okay, if you don't have any opinions, so I will show my answer. So, like you, as you like you see in the video, we have to make the solar panels floating in the ocean, and also it should have the property of saltwater resistance, and yeah, it also have the property of wave and current mitigation, and because of the solar energy is located in the ocean, so the transmission and the storage system should be enough to send the electricity to the land. So I will move to the bioenergy in ocean. So I will also show the short video of this one.
Ocean algae absorb 1/4 to a third of global CO2 emissions every year. But all algae do this even if they aren't in the ocean. So no matter what it's used for, growing algae captures CO2. And humans have been using algae for thousands of years. Indigenous peoples from the Americas to East Asia are the original seaweed farmers. Seaweed was even mentioned in the oldest known Japanese poetry. From Ireland, a type called Irish moss is used worldwide as the food additive carrageenan. Algae also helped people there survive the Great Famine of the 1840s. Today, algae aquaculture is most well developed in Asia, where it makes up a large part of the cuisine. It can also be in toothpaste, cosmetics, and medication. Growing algae for these products captures CO2, but greenhouse gas reduction is not the main aim. That's about to change, because using algae as animal feed, fertilizer, and bioplastic also diverts emissions from polluting industries. Its impact is effectively doubled. Let's talk about plastic. Some algae naturally contain and produce a bioplastic called PHB. It can replace polypropylene, the second most widely used traditional plastic. In this landmark paper, Moritz and other researchers modified blue-green microalgae, or cyanobacteria, to produce more of it.
Using some metabolic.
Okay, so let's talk about how can we use bioenergy resources to generate renewable energy. So this is the schematic of producing the bioenergy from the bioenergy to produce electricity or biofuel. Is there anyone can describe this schematic? No one? Okay, then. So by using sunlight from the sun, and we can harvest algae from the in the ocean, and by using algae, and also use a process in here, we can change the algae to ethanol fuel or animal feed and biodiesel fuel. And also we can use that kind of fuel to generate the electricity in the power plant. So this is the kind of processing that can convert the biomass to ethanol or biogas or biodiesel. So today's the last part of today's discussion session. So can you tell me the pros and cons of bioenergy in ocean? No one.
For cons,
One pros
I think,
is that we can. Sorry.
sorry. You can go first.
Okay, so my idea was that one of the pros is that you can use waste of bio exploitation like agriculture to make energy.
Oh yeah, that's a good point. And can you tell me cons? So I can give you the hint. So if we do not control the algae, then how does it happen if there is too many, or yeah, how does it uh how does it what does it happen in the ocean if there is too much algae? If we can't control the if we cannot control enough, there are nutritional pollutant can be happened in the ocean. Is there any opinion more? Any opinion?
Yesen has something to talk. Yesen, Yesen?
Maybe it's hard to control the whole system because I don't know, we are using the algae system.
That's also true. Thank you for answering my question. So this one is my opinion. So algae itself can absorb the carbon in the air, so it has a carbon sequestration property. And as you see, we can make the ethanol and biodiesel jet fuel by using biomass. So it has a diverse fuel types property, and lastly, we don't have to use a lot of fresh water usage because we harvest the algae in the ocean. So these are the pros of the bioenergy in ocean, and there are also cons of bioenergy. So like you said, it is very hard to farm the algae in the seaweed because it's very it has a very unpredictable growth rate, and also there's a nutrient and pollution concerns in the bioenergy section. So thank you for listening my discussion session.
Thank you. Yeah, you had a good preparation for the discussion session. Enjoy the long discussion now. Any other question or comments? Any schedule or oriented or any other? No? Then we can see on Thursday at the same time. On only Zoom only. Less one more. All right. Bye now.